part 3 of our exponent series. We are going to review this worksheet. So let's start at 64 raised to the 5/6 power. Okay. Whenever you see 64, 32, 8, always think about 2 as being part of the answer. Okay, the way to handle this is change this to a radical. Here's your root because it's underneath the fraction line. Goes there. 64 to the 5th power. We can also go ahead and take this, flip it up, and add parentheses. So this becomes the 6th root of 64 raised to the 5th power. Again, always be suspicious of 2. It turns out that 2 times itself 6 times does in fact equal 64. Okay, so the 6th root is asking yourself, what number times itself 6 times itself 6 times gives you the radicand? This is the radicand. Okay. So what number multiplied by itself 6 times gives you that? And the answer is 2. So this becomes 2 raised to the 5th power, and 2 raised to the 5th power is going to equal 32. Okay, so back to this concept. Again, if you're not sure what 6th root means, you don't deal with it that often. What do we deal with? We deal with square roots a lot. Okay, you know, just visually, square root of 9 is 3. Okay, so what does the square root mean? It means what number times itself twice gives you the radicand. And you know that number is 3. Same thing here. 6th root of 64. What number times itself 6 times gives you the radicand? Answer is 2. Let's move on to the next one. The next one is 729 raised to the negative 2 over 3 power. Okay, first thing we do when we see this situation of a negative exponent, we take the reciprocal and we change the exponent to a positive and we apply the power rule. 1 to any power is going to equal 1. So now in the denominator we have 729 to the positive 2/3 power. So let's just focus on that for a while. We convert that to a radical. Here's our root. Take this, we flip it up top. Okay. Cube root of 729. Okay, whenever you see 9s, you think about 3s and 9s. Okay, what does the cube root mean? The cube root means you're looking for a number, we don't know what it is, that when it's multiplied by itself 3 times, you get the radicand. Okay, we don't know what that is, but we know it's going to be the same number multiplied 3 times to get that radicand. Just like if we had a square root of 16, you know off the top of your head that is 4. What does the square root mean? It means you're looking for a number. We don't know what it is. It's multiplied by itself twice, and you get the radicand. And what is that number? That number is 4. So over here, we are looking for a number multiplied by itself 3 times. And again, when you see 9s and you see 3s, think about 3s and 9s. They go together. It turns out that 9 times 9 times 9 is 81 times 9, and that's 729. Okay, so you end up with the cube root of 729 is in fact 9. So now you have, what do we have here? We have, this should be a 2, sorry. So we have the cube root of 729 in the denominator. Cube root 729 squared in the denominator. Okay, so we said that this becomes 9. So we have 1 over 9 squared equals 1 over 81, and that's your final answer. Let's go to the next one. 32 to the 3/5 power. Okay, again, when you see numbers like 32, 64, 8, always think about 2. It tends to be involved. Okay, 32 to the 3/5 power. So what's going on here? We draw our radical sign. This is our root. Put our base in, and there's the exponent. We take this, we flip it up. Now we have raised to the 3rd power. Okay, we're thinking about 2's. Okay, what does this construct mean? It means we have some number multiplied by itself. It's the same number 5 times. Why 5? Because that's our root. What number multiplied by itself 5 times gives you the radicand? The answer is 2. Okay, so you're going to have 2 inside. You're going to have 2 inside. It's going to be raised to the 3rd power, and your final answer is 8. Let's go to the next one. Okay. We have 27 over 8 raised to the -4/3. Okay. First thing we do when we see a negative exponent, we flip what's inside. We change the exponent to its positive version, and we apply the power rule. Okay, let's take them one at a time. Let's take 8 to the 4/3. What does this mean? It's the cube root of 8 raised to the 4th. We flip that up and add parentheses. This becomes cube root of 8 raised to the 4th power. What does the cube root mean to us? This is what it means. There's some number multiplied by itself 3 times that gives you the radicand. What number is that? None other than 2. Okay, so now this becomes 2 to the 4th power, and 2 to the 4th power is, 2 times 2 is 4 times 2 is 8 is 16. Okay, so that's in the numerator. Yes. Okay, that's in the numerator. Now let's look at the denominator, 27 to the 4/3 power. Radical sign first, then the root. It's neater. 27 to the 4th power. We're going to flip that up. So now we have 27 to the 3rd power. Cube root of 27 raised to the 4th power. What number times itself 3 times gets you the radicand? Answer is 3. So now we have 3 to the 4th power, and that equals 81. So our final answer for this problem is going to be, this was our numerator. Here's our denominator. Our final then is going to be 16 over 81. Let's do another one. 27 to the 4/3 power divided by 9 to the negative 5 over 2. Okay. Let's do this one first. We have the 4th. Take that, flip it up. Does the cube root mean to you? Cube root means there is some number. We don't know what it is. Multiply by itself 3 times. That gives you the radicand. Answer is 3. Okay, so in our first term, it's going to be 81. Put a box. Divided by, let's take a deep dive into 9 to the negative 5 halves. This can be written as 9 over 1 to the negative 5 halves. What do we do with the negative exponent? We flip what's inside. It becomes 1 over 9. We change the exponent to positive, and we apply the power rule. 1 to the 5 halves is going to end up being 1. So now we're going to look at 9 to the 5 halves power, which is in the denominator. This is going to end up being the square root of 9 raised to the 5th power. It's going to end up being 1 over 3 to the 5th power. And 3 to the 5th power is going to be 243. So it's 1 over 243. Okay, so now we have 81 divided by 1 over 243. Okay, there's a couple ways to handle this. We are not used to seeing this. What our mind is used to seeing is the following. 81 times 1 over 243. We can handle that. But we're not used to seeing this laid out this way. There's 2 ways to do this. The way that I prefer is to use keep, change, flip. Whenever you're dividing and there's a fraction involved, you can use keep, change, flip. Change the 81 to 81 over 1 divided by 1 over 243. Keep the 81 as is. Change division to multiplication. Flip this to 243 over 1. And your final answer is 19,683. Now, is there another way to do this? 81 divided by 1 over 243. Well, you'd have 81 big fraction over 1, 243. You can multiply the bottom by 243 and the top by 243. And you get the same answer. 81 times 243 gets you that. Let's do one more. Okay, we have 4th root. Again, radical first, then the root, divided by. Okay. This is the same as, okay, is there anything we can multiply by 4 to get 64? Turns out there isn't. Okay, 4 might come to mind. Doesn't work. Okay, so we have to be a little more creative here. Okay, we're going to change this to 16 times 4. Fourth root. Same thing. All we did is change the 64 into 4 times 16. That's going to be the same as the fourth root of 16 times fourth root of 4. Now, there is a fourth root. What number times itself 4 times is going to get you the radicand? And the answer is none other than 2. So this becomes 2 times the fourth root of 4. So our problem initially was 2 times, fourth root of 64 divided by fourth root of 4. So now this becomes 2 times fourth root of 4 divided by fourth root of 4. Okay, if we call this number D, as in Dartmouth, this is going to be the same, D. What we're looking at is 2 times D divided by D. That's like saying 2 times D over D, and you're going to get 2. So that's going to be your final answer. So don't let all this confuse you. At the end of the day, you have 2 times something divided by that same something. 2 times something divided by that same something. 2 times something divided by that something. 2 is your answer.